I know that grid-tied solar has been really established in the market for quite some time now. I would say probably about 10 years. But residential energy storage, grid-tied residential energy storage, is gaining a lot of popularity now. And there are some basic but not so simple questions that I think everybody should be in the know about. And so I want to just take short webinars to answer these questions. And so today, our first question that we're going to address is, why does my solar PV stop producing power when the grid goes down? So I just want to tell you a little bit about myself, explain the basics of grid-tied solar so that we can understand why it goes down when the grid goes down. And I really want to just focus on that question. I don't want to spend too much time, which is kind of on the secondary question, being how can I have a solar system that does maintain power during an outage? And I think that question deserves a lot more time and attention. So I will get to that in the future. But for today, we're going to focus just on grid-tied solar going out when an outage occurs. And that's the only thing I really want you to get out of this discussion. A little bit about me. My name is Madeline. I have been in solar for a little over 4 years, and I've been working in residential solar plus storage systems during that entire time. So I've seen some of the more tried and true battery-based systems that have been around for a long time have stable success. And then I've also seen a lot of new residential grid tie offerings come into the market. So there's definitely a lot of momentum coming with new products. So I want these questions to be second nature to all of you. And even if you are a solar installer and you have decades of experience, the intention of this webinar is so that you can explain these sorts of questions to an everyday person, whether that might be a potential customer or a neighbor of yours. The more that everyone can understand these questions, the general knowledge base will increase, and then more people will be just cognizant of the types of systems that we're seeing in different people's homes more and more. So my goal is to support installers to be as confident and skilled at installing battery-based systems as they are at grid-tied systems. And I want to accomplish this by building strong relationships with our vendors so that installers have the resources from the manufacturers themselves and just know how to be supportive in a general sense. So my goal is really to support products getting into installers' hands so that everyone has a good basis of understanding for projects that are involving batteries. This is a schematic of a traditional grid-tied system that I'm sure everyone is relatively familiar with. So I'm just going to briefly go over it. The sun shines on our photovoltaic panels, and this creates energy. Excuse me, this creates power. So there is power instantaneously coming out of these panels. It is DC power that's going into an inverter that is creating AC power. And this AC power is either going into your home, into your AC loads of your home, or if the loads in your home are not using all of the power that is being produced, the power from the PV can go from the inverter to your grid. So the meter is, it's a bidirectional meter that would allow you to feed your solar power back into the grid or take power from the grid, in this case, when the sun isn't shining or when it's nighttime. So when a grid tie solar system is installed, an interconnection agreement is signed. And an interconnection agreement is between the homeowner or the person that is managing the site and the utility. And one of the requirements of this interconnection is that the customer, being the PV person, shall not feed the cooperative, in this case, let's just call it the grid. The PV shall not feed the grid when the grid is de-energized. And the reason being is to comply with IEEE 1547. So IEEE stands for the Institute of Electrical and Electronics Engineering, and this organization is established to meet technical, safety, and regulatory needs. So in order to comply, 1547 is created as a standard for interconnecting distributed resources with electric power systems. So when you sign your interconnection agreement, you are agreeing to not backfeed the grid. And the reason being is that to prevent backfeeding the grid, if people were to, let's say on the other hand, if the grid goes down and your solar continues to create power, if it were to feed the grid, this is going to cause a hazard, because during a grid outage, the grid is being worked on. The utility is trying to work hard to get everything back up and running. And so when there's personnel working on the utility grid, those lines cannot be active. There can be no voltage flowing through those lines. So to prevent any voltage from flowing through the utility grid during an outage, we have to turn our system off to prevent any of that power going back to the grid. And this concept is referred to as anti-islanding. So you will not, you are agreeing that your inverter will shut down within 10 cycles or less so that no more power is being fed to the grid. That is with a system of this nature. So I want to just go through this one more time. When the grid powers down, the inverter was receiving a signal from the grid saying, the grid is up, I'm receiving a frequency, we're going to work business as usual. The inverter is going to take DC power in from the PV and put AC power out. When the grid goes down and the inverter loses this signal saying, stay on, it shuts off. The inverter loses its signal and it shuts off, which means that the PV is not going through the inverter, so the house is not receiving any AC from the inverter, and the house is not receiving any AC from the grid. So because this grid has gone down, the house has lost both grid power and PV power during this time. So we are out. I do want to address that with a grid tie system like this, when the grid goes down, you lose power, but by adding an energy storage system, you are capable of generating an island of sorts by enabling your PV to continue to work by isolating yourself from the grid. That's the key, is that when the grid goes down, you have to find a way to isolate yourself so that you can continue to power your home, whether that be through the PV that's still from when the sun is still shining, or if that's through a battery, an additional battery-based power source, or a generator. So if originally we had a site that had PV and a grid tie inverter, in order to stay up, in order to keep producing when the grid goes down, we have a few more components that we definitely need to add. That's a hybrid inverter, also known as a battery-based inverter, a transfer switch, and a battery. So the transfer switch is the step that says, I am going to turn and I'm not going to let any of the PV power go back to the grid. So I'm taking that switch and I am isolating the grid and I'm saying, okay, the solar is only going to power the house. Then by adding the hybrid inverter, that can act as a grid forming element. And the reason being is that the grid tie inverter needs that signal from the grid saying the grid is up, the grid is working, the grid is functioning as usual, so then the PV inverter can function as usual. But in the outage, the signal is no longer there, so the grid tie inverter doesn't know when to turn on until it sees this signal. But when our transfer switch flips, then the hybrid inverter is signaled and it says, oh, I'm ready to turn on, and the hybrid inverter can create the signal that the grid tie inverter sees. And so the grid tie inverter knows, okay, everything is okay, I'm ready to turn on again. And then in this case, you can have the PV to give the power to the house to immediately use on the loads, or you can take that PV and store it in a battery. So that's how we're able to add these components to a system to establish a new connection when the grid goes down. So here is another kind of sneak peek, if you will, to what are the steps to addressing storage needs of a site. Because if you think about the grid going down, when your whole house turns off, you kind of go into, emergency mode. This is, everything is down. What do I need? What are the essentials that my house and my life need to function? Likely, the first thing that comes to mind is your refrigerator. You definitely want your fridge to stay cold. You probably want a couple lights. Let's say you just stick to your kitchen. If the grid goes down and you definitely need some appliances and power, you want your fridge, you want some lights in the kitchen, and let's just say that's it. We've identified the fridge and the lights as the loads that we really want to work when the grid goes down. Then, when you select a hybrid inverter, you select that hybrid inverter based on those critical load sizes. So the good news is with a fridge and lights, that's certainly smaller than the entire loads of your home. So you're able to size the hybrid inverter based on those loads. And so the smaller it is, of course, the more affordable your inverter selection can be. Then with these loads, you've sized the inverter. You also want to come up with how long do I want these critical loads to remain on? So with the fridge and the lights, let's say I definitely want to keep the fridge functioning and lights on at all times for 4 days. So for 4 days, you just look at the power needed for those loads multiplied by 24 times 4, a full day for 4 days, and that establishes your battery bank size. So I know that this kind of was a little bit of a short amount of time to spend because I want to go into detail later on how do you go about identifying the critical loads? How do you know which hybrid inverter is right? Because there are a lot of options. In this case, in AC coupled systems. And the reason this is AC coupled is because we already have solar. So we're adding the hybrid inverter, the battery bank, and the transfer switch on top of an existing system. So we want to make sure that we're picking the right inverter based on the fact that we already have a grid tie solar system and a grid tie inverter, and then pick the battery bank based on how you want to use it. And so in our case, if it's only when the grid goes out, we can make an assumption or decide to assume that it's going to be used, if there are 5 outages over 5 days, and that's going to be 25 different days, that sort of thing. So you say, how long do I think I'm going to be needing my battery used on a regular basis? Okay, that's kind of the overview. This is my answer to why does my solar stop producing power when a grid outage occurs. I hope that this was a sufficient session in answering that question, because that's really what I wanted to accomplish. And one last thing I want to leave in your minds is if you are in the greater Austin, Texas region, or if you are in Southern California, we have some in-person storage-related events. Next Monday, we have the roadshow in Austin, and then the following Tuesday, we have the event, and that is in Orange, California. So that's all I have. Jamie, if we want to address some questions, I'm happy to do so at this time.
Hello, everyone. Please feel free to leave any questions, comments in the chat box. We'll leave it open for a moment here to give you some time.
I will at least say that I'm glad there are no questions, at least for this topic, because this is definitely kind of the tip of the iceberg in terms of how to address storage in general. So I'm glad this was generally made sense.
All right, thank you, everybody. I appreciate you taking the time out of your day to join us for our first series with Madeline. We appreciate your time as well, Madeline, and we look forward to seeing you all on the next one. Have a wonderful rest of your week.
Thanks, everybody.